Hi, okay, welcome to session 7. We are looking at graphs today. We've got the normal recap to start us off. So I'd like you to hit that pause, have a good go at those questions, look things up if you need to, of course, and then press play when you're ready. Okay, so those are the answers. Again, feel free to hit pause so there's no sort of pressure of time. Mark through, and I'm just going to mention the ones I've highlighted just briefly before we move on. Okay, so the only reason that I'm mentioning them is because you can't see all the workings out. And if it's gone wrong, you might want to have an indication at least as to what might have happened. So for this question here, you needed to expand that bracket first. Get rid of the brackets, then you would have had 3x minus 6. You move the smaller set of x's first, which would have meant 7x take 3x was happening, giving you 4x, and then it would have just gone into a normal basic. So hopefully that went well. This one is just a reminder that you can swap them around if you need to. You might have done it up here as well. And then over here, you just need to be really mindful of this negative going on here. -4 times -4 makes a positive 16. And then you've still got that minus there. And I know that those negatives can really cause a problem sometimes. So fingers crossed, they are not being pesky in any way for you. Okay, I've just noticed that I have forgotten to put the answers in for question 2, the generating sequence question. So I'll just pop those in now for you. It's, I'll squeeze it in there, -2, 3, 8, and 13. Sorry about that. Okay, so we are looking at straight line graphs first, and then we're going to be looking at a graph that has a curve in it. It's the quadratic graph. So we're going to do both in this session. And it might be that once we've done the straight line, you want to take a bit of a break and then come back to the second part of the lesson. It might be that you're feeling fresh enough to work through the whole thing. That is obviously going to be your decision and your choice, okay? So let's get really stuck straight into what we're going to be doing today. So we know from our reflections that the lines on this grid all have their own very special names. We know how to name vertical and horizontals. We know that is x equals 2, and we know that is y equals 3. But what we're going to do is we're going to develop our knowledge of these types of lines or that type of line. And every single line that I could possibly draw, no matter what angle I draw it at, has its own unique name. Now we're starting with our understanding in just how to draw them at this stage. What we're going to do is try and remember that we need to make a link. We've got to remember that when it comes to the exam, something's got to trigger in our head. Now, when we draw these, we are always given a grid. So that's the first thing that we can observe in the exam, okay? Right, this is a question that has a grid. If this question also has a sentence along the line of draw the line y equals 2x plus 1. If it has that, and the key bit, to be honest with you, is really that bit there. If you've got y equals, it doesn't matter what they've got that side. If you've got y equals and the grid, you have to draw a table. That's what you want your brain to trigger. Okay, now the length of the table that you are going to draw, again, will be given to you in the question. So it will say something along the lines of draw the line y equals 2x plus 1. between the x values -2 and 3. They might use an inequality. It doesn't matter how they pull that together. In the exam, we're using a general grid to help us with all these questions. In the exam, the x-axis tends to have the numbers specific to the problem as well. When we get on to some of our consolidation work, we are going to see real exam questions, which will enable us to see exactly how it will appear. So you will get exposure to that, which is important. So the first thing that you do is you draw a table. So I'm hoping that this is going to work. It's like magic when I prepared earlier. So the table is always going to look the same. It's going to have a X on the top and a Y on the bottom. It's going to have the numbers that we're told to use for X along that X row, and our Y is our job. We've got to work out the Y. Y is going to equal whatever this creates. Okay, we'll see the whole thing come together. Now, throughout this, I'm just going to use the same table. Like I say, in the exam, it may vary just very, very slightly. And we will see some of that variation when we do some consolidation work. So don't worry about that. It will happen. So this is how we do it. We know that the rule y equals 2x plus 1 has been given in the question. 2x plus 1 means 2 times whatever x is plus 1. When I go to the table, x is taking loads of different values. So I've just got to pick one of them in order to work it out for the number that goes in underneath. And I'm always going to work at this end rather than at this end for the simple reason that here I have negative numbers and here I have positive numbers. And generally, positive numbers are easier to work in. So my first x value is going to be 3. So I've got 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. All right, so I've got y equals whatever that is. I've put 3 into the rule, and I've got the number 7, which goes with the 3. And then I repeat that process. So this time, I'm going to put the number 2 into the rule. The rule is 2 times 2 plus 1. Okay, so I have put 2 where the x is. 2 times 2 is 4, plus 1 is 5. So when x is 2, y is 5. 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So I've now got 3 when x is 1. And I can keep going like that, or because it's a straight line, I can spot a pattern. I can see that to get from 7 to 5, I need to take away 2. And to get from 5 to 3, I take away 2. So if I keep this pattern going, I can find the rest of the numbers, okay, without having to do all this work here. I have to do it to get myself started. There is no way I can get around that, but I can reduce the number I have to do by spotting the pattern. Okay, so 1 take away 2 is -1, and -1 take away 2 is -3. So now I've completed all the values in the table, I can plot them as coordinates. Remember, a coordinate is along the corridor, along the x-axis, and up and down the stairs. So I've got x and y. So here, I'm going to change my color and hope it doesn't get too colorful. Here, I've got x is 3, y is 7. X is 3, y is 7. gets plotted there on the coordinate grid. My next coordinate is 2, 5. 2, 5 is plotted here. I've then got 1, 3, 0, 1, minus 1, minus 1, minus 2, minus 3. So what have I done so far? I've been given a rule. I have made a table. I have done a load of maths. I've used the rule to help me find all the y values. And now I've plotted the coordinates. But I must remember I'm drawing the line. At the moment, I can't see a line. All I've done is drawn coordinates. And I see loads of students that stop at that stage. They put the coordinates in and then they don't draw the line. So it's really important to remember, get your ruler, draw right through all those points. And that is the answer. That is the line that we call y equals 2x plus 1. All right, let's have another look at this with a different question, okay? So we are going to draw the line y equals 3x plus 3. Okay, and we're going to do it for values of x from, and this time we're going to do it from -3 to 1. I'm going to draw the table from scratch on this one because it's very different to the last one that we did. Okay, so we've got x and we've got y, and then we've got -3, -2. Whoops, don't know how that is supposed to look like -2. That's better. -1, 0, and 1. And it doesn't have to be anything, you know, any neater than that. As long as it's organizing our numbers, it's going to work. So my rule is y is going to equal 3 times whatever x is plus 3, okay? So that rule there, I have written here. I've just expanded it out so I can see the maths. And then I am going to put 1 from the table where the x is. So 3 times 1 plus 3. 3 times 1 is 3 plus 3 is 6. Then I'm going to put the 0 in. 3 times 0 is 0 plus 3 is 3. 3 times -1. Well, 3 times -1 is -3. -3 plus 3 is 0. And I've probably got enough now to be able to spot it's going down 3. So I can just finish the rest off by keeping on taking 3. So 0 take 3 is -3. -3 take 3 is -6. Now I can transfer the numbers in the table and plot them as coordinates on the grid. So I've got 1, 6. I have 0, 3. I have -1, 0. -2, -3, and -3, -6. And then I'm going to draw my line carefully. Hopefully my software will work through all the points. And that is the line y equals 3x plus 3. It's only drawn from start to finish. It's constrained by the table. If I'd extended the table, made the grid longer, whatever, that actual line just goes into infinity. It's just held short by the conditions of the question. Okay, I think we should do another one. This time I want you to have a go. So you're going to press pause and hit play when you're ready. So you're going to do y equals 2x minus 2. And we're going to use the x values from -2 to 3. Okay, so I want you to, like I say, pause look at the work we've done so far, have a really good go at this and hit play when you're ready. Okay, so we've got the rule that y will equal whatever 2 times x is minus 2. My biggest x is 3, so I'm going to be putting 3 here. I've got 2 times 3 minus 2. So 2 times 3 is 6, minus 2 is 4. 2 times 2, the next x value. 2 times 2 is 4, minus 2 is 2. 2 times 1 is 2, minus 2 is 0. And now I have enough to see if there's a pattern. There is. Really important because not all rules give the same patterns, okay? This particular style of question does. So I'm going to take away 2, take away 2, take away 2. So if you got that right, you already have 2 out of your 4 marks. Now, plotting them, 3, 4, 2, 2, 1, 0, 0 minus 2, minus 1 minus 4, and minus 2 minus 6. Drawing the line gets me the other 2 points. That is a 4-mark question in your GCSE. Unless you're unlucky and they've decided to only give 3. I think I've only ever seen that once. There's usually 2 marks for your table and 2 marks for your graph. Okay, well done if you got that right. So one more before we go into practice. So this question, I'd like you to draw y equals minus 2x minus 1, and we'll do it between the same values. So, oh, I'm not even writing between, honestly. Let's try that again. There it is. Between x values, minus 2 to 3. Okay, so yes, I have written something slightly differently, but like I'm always saying it to you, aren't I? A method is a method for a reason. It works. You have to trust it. So we don't do anything differently. We do exactly what we have learnt. It's a y equals question. I've got a graph. I'm drawing a table. And then I'm going to be substituting to work out those missing values. So pause and hit play when you're ready. Okay, so y is equal to minus 2 times whatever x is, and then minus 1. So there's a lot of negatives here. I know that I am going to have to be very careful and take my time. The first number I'm going to put in is the 3. That is my pattern. That's how I approach these questions. I'm not going to change it now. So 3 is going to go in. I've got minus 2 times 3, and then I've got to minus 1. So minus 2 times 3 is minus 6. Minus 6 minus 1 is minus 7. So minus 2 times 2 minus 1. Minus 2 times 2 is minus 4. Minus 4 minus 1 is minus 5. Minus 2 times 1 minus 1. So minus 2 times 1 is minus 2. Minus 2 minus 1 is minus 3. And now I'm going to look for the pattern. What I can actually see is these numbers are going up that number line. So I've gone from minus 7 to minus 5, and I'm on my way to that 0, adding 2 each time. So if I add 2 to minus 3, I'm at minus 1, and then at 1, and 1 plus 2 is 3. So those are my coordinates, and that is what I am now going to plot. So I've got 3 minus 7, 2 minus 5, 1 minus 3, 0 minus 1, minus 1, 1, and minus 2, 3. Draw that line in. Try and go through each point carefully. You'll use a ruler, it'll be much easier. And there it is. The line y equals minus 2x minus 1. So this line's very different to the others that we've done. All the others have gone upwards. They're positive gradients. That's the difference. And then this one is going downwards, and it's a negative gradient. And that gradient can be seen here in front of the x. That was what's different to all the others that we did. If you look at all your graphs, they had positive numbers in front of the x. And that positive value was creating a line that went up. And the difference here is a negative value has created a line that goes down. The other thing to say about those numbers, and again, something that I hope you can see, is the steepness. So if you look at your 2x line and your 3x line, you'll see the 3x line is steeper. And that's another thing that the gradient does. It gets steeper and steeper and steeper, the bigger and bigger the number. Okay. So it's just a little bit of background between what's going on. So what you're going to do is you're going to have a little practice for me. I've got 4 questions. You've obviously got the printable, so hopefully you are in a position to print. And then the answers are going to come up. I've got something else to link when you see those answers. And then we're going to move on to the quadratic. And like I say, at this point, you might feel, this has been a long session. I'm going to take a break and then I will carry on with the new piece of learning when I'm fresher. So entirely up to you. Okay, so let's look at the answers. I'm just going to disappear and zoom in a little bit. In fact, I should be all right. Let's go in just a little bit there. Okay, so those are the first 2. Hopefully they've gone well. But what you're going to draw your attention to is the highlight that I've done. So I've got this and this highlighted, and then I've got this and this highlighted. And if you look, the minus 1 on the end of this equation is the minus 1 on the y-axis where the line crosses it. I've got a minus 1 here on the x. That's got nothing to do with it. The minus 1 on the y is where it crosses it. And this is true of everything that we've done. Again, you can look at all the examples that we did. The end number is where the line is crossing the y-axis. Let's look at the answers to the last 2. So those are the answers. Hopefully you're ticking and happy, skipping around the room. But look at what's happening with that. Okay, that's crossing at minus 3. That's crossing at positive 1. It doesn't matter if the gradient's negative or positive, you are going to see that. So that's just a little extra as well. We do go into this graph in a little bit more depth in the grade 4 course, but the most common questions that you get asked are to draw them, and we've covered that here, which is important. Okay, so we're going to move on to our quadratics. Now, quadratics are exactly the same. The only difference is the rule is a little trickier. Okay, so let's take a look, first of all, at the simplest version we possibly can, which is y equals x squared. Okay, and that is it in a nutshell. It's going to have a power on the x, okay? And there could be more going on, but there will be this power 2 on the x, and you'll see that in all of our examples. So we're going to do everything now between the values. So we're going to take the x values as minus 2 to 2, okay? So we draw in our table, which I'm not going to do. I'm just going to use this one and erase this last bit that I don't need. Everything else, honestly, everything else is the same. So you've got your table. You've got exactly what I was saying to you right at the beginning. You've got a question with a y equals and a coordinate grid. So boom, trigger the table. These are often drawn for you and you're just filling in a couple of missing ones. But if it's not there, you need to know it's the same process. So let's crack on with it. Y is going to equal x times x squared. So when x is 2, it means I'm going to put 2 here. I've got 2 times 2, which is 4. I've then got 1 times 1, which is 1. 0 times 0, which is 0. Minus 1 times minus 1, which is positive 1. 2 negatives make a positive. Now I'm at a stage where I can start to see a pattern in the table. So this was going down 3, then it went down 1. Now it's just gone back up 1. Okay. So I'm guessing I've gone 4, 1, 0 back to 1. This is probably going to be 4, but we're going to do the maths to make sure. So we've got minus 2 times minus 2. 2 times 2 is 4. The 2 negatives make a positive. So absolutely, indeed, it does. So let's plot this. I've got 2, 4, and I've got, what did I have? 1, 1, 0, 0, minus 1, 1, and minus 2, 4. Okay. And what this is doing is it's creating a kind of U shape. It's creating a graph with one bend in it. So I am going to do my best to draw through. I always find turning it to the side helps a little bit. Down and round. And that is y equals x squared. It should be a curve, so never draw them up with straight lines. As soon as a graph has a bend appearing, then it's going to be a curve, and they want that as smooth as possible. X squared creates this kind of smiley face. If you've got a -1, it would create a sad, it would flip it, but the coordinates would naturally happen for you, so you don't need to think that hard about it. One of the interesting things is the previous work we did where everything was y equals like 3x plus 1 or 2x minus 2 or whatever it was. The point I'm about to make is that the x was just a single x on its own. No powers, nothing else, just a single x. And a single x created a straight line. As soon as you put a power 2 on the x, it creates a bend. Okay, so you end up with a graph with a bend in it. If I asked you to draw y equals x cubed, now that's an x with power 3, and it actually has like almost like 2 bends in it. If I did an exaggerated version of one I've just done, you can see the 2 bends easier. It's like it's saying, okay, I'm gonna go back down. Oh no, I've changed my mind. I'm gonna go back up again. So a single x gives me a straight line. Power 2 is 1 bend. Power 3 is 2 bends, and so on. Okay, we're not doing power 3 today, so don't worry about that. It's just nice to give you this information as it comes up, I think. Okay, so next question, we're going to do y equals x squared plus 2. All right, I think you could probably have a go at this one. It's not the trickiest rule. We'll do it from the x values, and we're going to do them all between -2 and 2, okay? So hit that pause and press play when you've had a go at this. Okay, so we've got y is equal to x times x plus 2. Write that rule out. I see a lot of students, I suggest that they do it and they don't, which is fine. But I also then see them get themselves in a right pickle and end up confused. This really does help, just keeping it all clear. We can see what we're doing. So 2 is going in first. So 2 times 2 is 4 plus 2 is 6. Then it's the turn of the number 1. 1 times 1 is 1 plus 2 is 3. 0 times 0 is 0 plus 2 is 2. Right, minus 1 times minus 1 is 1, plus 2 is 3, and I can see it's turned on itself. It's going down, down, and now it's going back up. So I don't need to do the next one. I can see it's going to be 6. Now I'm going to plot 2, 6, 1, 3, 0, 2, minus 1, 3, and minus 2, 6. And I'm going to draw that curve. And there it is. It's not the most perfect curve in the world. What they're looking for is no straight edges and you going through the points. Okay, if you're a millimeter off one, don't start trying to redraw it. They can see what you were trying to do and it will get you the mark. But if you're miles away, then yeah, you might want to think about redoing it. If you got that right, then really well done. Okay, we are going to step it up now. And we're going to do y equals x squared plus 2x. Again, we're going to do it between minus 2 and 2. And I really, you are already good at this because you did the session with substitution. We've already practiced this skill earlier in the course. So we should be feeling very comfortable. It's transferable skills, isn't it? We did generating sequences, doing it this exact method. It's the same thing. So don't overcomplicate it. Don't think it's harder than work you've done before. It is stuff you know. Press play when you've had a go at this. Okay, here we go. I have got my y will equal whatever x times x is plus 2 times x. There are a lot of x's in this. Everywhere there is an x, I will be replacing it with the number from the table. So the first number is 2. So I've got 2 times 2 plus 2 times 2. Well, 2 times 2 is 4. 4 plus 4 is 8. Now I'm going to put the 1 in. 1 times 1 plus 2 times 1. Remember, it is only the x values that will change. So this 2 in the rule originally will stay absolutely there throughout. All right. So 1 times 1 is 1, plus 2 times 1 is 2. 1 plus 2 is 3. Now I'm going to stick my 0 in. Plus 2, sorry, I put a 1 there, times 0. 0 times 0 is 0, plus 2 times 0 is 0. That is going to give me a 0 there. Okay, we've got minus 1 times minus 1, plus 2 times minus 1. Now I've got a lot of negatives in there. So once again, taking my time so I don't mess up. I'm actually going to do this so I can see it. I'm not going to try and hold it in my head. That is when I'm likely to make a mistake. Minus 1 times minus 1 is positive 1. 2 negatives make a positive. Okay, then this bit here is 2 times minus 1. I've got a positive 2 and a negative 1. 2 times minus 1 is... minus 2. Dear, that didn't come out very well. And then 1 minus 2 is minus 1. So that's what we're going to put in there. Okay, I'm starting to run out of room, so I'm just going to rub that bottom bit out. and put the next number in. It's still going down. I can't take any shortcuts because it's going down, down. Oops, it's still on my rubber. There we go. It's going down, down, down. So there's no turn up, which means I can't actually guess what that -2 is going to be. I'm literally going to have to do it all by hand. So -2 times -2 plus 2 times -2. -2 times -2 is +4. And then this last bit that I can see, 2 times -2 is -4. And 4 minus 4 is 0. I can see the turn now. So that's good. I could guess, well, I know for a fact that -3 is going to come back up, isn't it, to the 3, but we won't plot it. So we've got 2, 8. We've got 1, 3, 0, 0, -1, -1, -2, 0. And like I say, if we wanted to, -3 would be 3 and -4 would be 8. So the graph that we've been asked to draw is that, okay? If we included this bit as well, you can sort of see that big smiley face that we spoke about. If I drew it well enough, that would be a nice smooth curve. But those extra 2 plots weren't in our table. We weren't asked to do them, so we wouldn't draw them. But I think it's quite nice to see how that coming down, 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 once it's twisted on itself, it really does come up with the same values because we do have symmetry. So through this lowest point here, I actually have a mirror line. I could fold that and it would fit on itself. And that's one of the things that this graph does. The quadratic graph will do that, which is quite nice. Okay, I think it would make sense to do maybe one more where the rule has just got probably as hard as it possibly could, just so that you've got that modeled and you've got a chance to try it with a walkthrough. And then we'll just leave it there and get straight on with the practice. So this time you're going to do y equals x squared plus 2x minus 3. So there's quite a lot going on with that. Same values, we'll do -2 to 2, okay? So I'll just set the table up, -2 to 2, and then just press play once you've had a really good go at that. Okay, so there's a lot happening. I need to take my time. So I know that my y will equal x times x plus 2 times x minus 3. Okay, the first x value is 2. So I've got 2 times 2 plus 2 times 2 minus 3. So 2 times 2 is 4, plus 2 times 2 is 4. 4 plus 4 is 8, and 8 take 3 is 5. And that's the first one done. Now I am going to do mine directly under those x's, so it's easy to see. X is now 1, so I've got 1 times 1 plus 2 times 1 minus 3. 1 times 1 is 1. Plus 2 times 1 is 2. 1 plus 2 is 3. Take off that 3, and I've now got 0. So hopefully you're looking at this going, yes, it's gone really well. Right, x is 0. Well, anything multiplied by 0 is 0. So if I take away 3, I'm at -3. So that one's not so tricky. Going into negatives now, so I need to really take my time. So -1 times -1 plus 2 times -1 minus 3. So -1 times -1 is 1. 2 times -1 is -2. And then I've got my -3. So 1 take 2 is -1. And -1 minus 3 is -4. Okay. Last but not least. -2. So -2 times -2 is 4. 2 times -2 is -4. 4 take 4 is 0. And then 0 minus 3 is -3. Okay, hopefully that went well. Now, this is really commonly on a calculator paper. So you can be using the calculator. You don't have to be doing this all by hand, but you do need to be very, very careful. If you just throw it into the calculator, and you could practice this now without any care, then the negative numbers here, all right, that section of your table will go wrong, which you don't expect it to do if you've used a calculator. When you do the, let's say, -2 squared into the calculator, if you put that in incorrectly, even though it feels like you're doing it right, the calculator is going to say it's -4, which we know is not true. -2 times -2, two negatives make a positive. But due to the way that the calculator has been programmed with BIDMAS, it doesn't recognize that you want to do a negative power 2, if that makes sense. So what you need to do, if you look at your negative key on the calculator, you will notice that it is in brackets. The calculator is really trying to tell you to use brackets, right? You don't always have to, which is why we don't always do it. But when a power 2 comes into play, it's vital. So for your calculator to work it out properly, you have to put that in brackets and then hit power 2. Then your calculator will give you this. So you've got to remember that detail or things are going to go wrong. So by all means, please use a calculator, make your life easier if that's what you would like to do, but be very mindful that the shape of the graph has got to do this. When it goes wrong, the shape of the graph kind of comes down and then it kind of goes off in a funny kind of angle. And there's really no smile even trying to appear. And again, that would be your alarm bells. That would be, oh, hang on a minute, something's not right. So just be mindful if you are going to do it like that. So I've got 2, 5, 1, 0, 0 minus 3, -1, 4, and then I had -2, -3. So curve it round and up we go. Okay, it's a lot of information, but it's a big topic. And if you're thinking, God, this is hard, it's because it's not grade 3, okay? It is grade 4, but for me, writing these courses, it was important that everything kind of came together in its topic area. There'd be no point in you learning how to draw straight lines and then having to do a completely other course in order to extend that. So I've brought it all together, and this is happening quite a lot in the course, isn't it? But I think it's really important to do it. Now, there's one thing we haven't seen. I'm going to quickly mention, because this I've seen happen quite a few times. You kind of plot some coordinates. Let's say those are our coordinates. And then you sort of come back round, and that's hopefully about right. I think it's not quite perfect, but the point is down here. If I'm coming down, 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 there's no point to go any further. So I'm tempted to go across to that one and then up, up, up. But that's just introduced a flat line. There is no line anywhere on a smooth curve. So what they're expecting you to actually do is to come down through the points, dip down a little bit, and then come back up. So if you get that situation, I call it no flat bottoms, okay? Nice and round, all right? I've made that look like a smiley face with eyes and everything, haven't I? Okay. Let's not look at that. These are your questions. Again, you've got the printable resource, so hopefully you're able to print that and that will make your life a little bit easier. And then we've got the answers on their way. And I also want to show you a little detail again. Okay, here comes the answers. So they are pretty good, don't need to be too huge. We might as well do one at a time. So taking a look at the first two, hopefully they've gone well. We had a dip situation on the very first one, didn't we? Where we had these two ones. So you had to just come in a little bit lower. But look, the end of this equation has +1 and it crosses it +1. The exact same thing here, -1 crossing it -1. So we saw this on the straight lines. It's absolutely true of these as well. So it's a really nice thing to know about these graphs. Yeah, we've got the 4 crossing it 4. We've got the -4 crossing it -4. This one went slightly off the grid, so we couldn't plot it. All right, that's a long session. I hope it's gone well. Obviously, we're going to carry on practicing this in our recaps and consolidations, but well done today. A big session. And I will see you next time.